All right, we're going to give everyone a second to log in and then we'll get started. All righty. Good morning, good afternoon, everyone, wherever you're joining us from today. Welcome to today's webinar, co-hosted by the New York Oracle User Group and Oracle partner Viscosity North America. We've got a great live webinar for you today. Please feel free to submit Q&A questions in the Q&A field, and our speaker will get back to you as soon as he can, most likely after he finishes presenting. So we've got Gerald Venzl presenting for us today. He's from Oracle Corporation, so I'm excited to see some great questions from the audience. That's all of you. So make sure you take advantage of that. We've got a full hour with him, so I really do hope you come up with questions along the way. Pop them in that Q&A field, like I said. And if you have any logistical questions for either Viscosity or NYOUG, you can put those in the chat field. We'll monitor the Q&A in case, but otherwise try to keep speaker questions in the Q&A and speakers for us on the back end in the chat. So my name is Monica Lee. I'm the marketing director here at Viscosity. Hopefully you're already familiar with me and Coleman, and you've been a regular to our joint webinars. But if not, Coleman's going to tell you a little bit about NYOUG. I'll follow up, tell you a little bit about Viscosity, and then we'll get started. So Coleman, I'm going to hand it over to you.
Thank you, Monica. Welcome, everybody, to our virtual webinar today. New York Oracle Users Group was formed in 1984 for the exchange of ideas, assistance, and support among users of Oracle software products. Next slide, please. You can connect with us on X, Meetup, LinkedIn, Facebook, and of course our website, nyoug.org. And also presentation webinars. You can see the whole list of webinars that we have since 2020. Just one moment, I want to thank, of course, Viscosity for co-hosting a series of webinars. I also want to thank Gerald. I'll get to Gerald in a moment, please. But I just wanted to reach out to everybody and let you know that we have a couple of webinars coming on July 19th. Basically, it's going to be mission critical AI with Oracle Exadata. And we're going to have July 23rd, Postgres table partitioning. On July 30th, we're going to have Unlock AI Potential with Apex. And August 6th, develop AI machine language driven apps with autonomous database 23 AI. So thank you again. And Monica, I'll hand it back to you.
Thank you, Coleman. All right, real quick about Viscosity. We are a full Oracle Stack consulting firm with our core expertise in Oracle database, including RAC, Oracle Apex. We perform near zero and zero downtime migrations for many of our customers. We are heavy in the performance tuning and high availability realm. We've also got decades of experience with infrastructure, including engineered systems. We were named Partner of the Year for Oracle's database appliance, and we offer a lot of managed services, training, workshops, things like that throughout orapub.com. That's also where you're going to see us post our recordings. So real quick on the screen right here, you'll see the three pillars that Viscosity is built upon: data, apps, and cloud. Across the bottom, you'll see items we offer, services we offer across all three pillars. Okay, on this slide, I'd just like to highlight some of the books that our folks have written. Together, I think our consultants have over 25 or 30 books. Newest ones are going to be here, Oracle Database Performance Tuning and Upgrading Oracle Databases. These two will be updated around Oracle Cloud World, so I believe that's in September. So take a look at that. But right now, these two are on 19C. All right here on this screen, you'll see some of my colleagues, excellent speakers. They are the executive management and managing consultants here at Viscosity. They're also part of the Oracle ACE program. So if you're not familiar with the Oracle ACE program, we're very proud of these consultants of ours because They're recognized by Oracle as wonderful technologists who are out there providing knowledge to the Oracle community. So hopefully you either follow their blogs, own some of their books, or see them at conferences around the globe. Or maybe you're a customer of ours and they're actually helping you guys day to day. So they're wonderful folks. And brilliant as well. So hopefully you follow them or you'll see them. I think our next conference, we've got Rich Nemick and Craig Shallyhammer, along with our Oracle Apex team, headed to ODTUG Kscope in Nashville. And then I think a couple of them, Rich, Gary, maybe, and Charles, were at Ascend earlier this year. Sean's been around the globe. Definitely follow them. They're great. Some of my favorite humans, really. And then finally, you'll find all of our recordings and slide decks for viscosity webinars, as well as NYOUG viscosity webinars, posted at www.orapub.com. You do have to become a member here, but we have free memberships as well as paid memberships. Paid members do get a couple extra perks, so I highly recommend checking that out. And I also recommend, if you're interested in those said perks, to ask your employer if they would reimburse you for these fees, because really it's just all continued education all around Oracle performance. So check that out. And I'm going to turn it back over to Coleman to introduce our speaker for the day.
Thank you, Monica. As I mentioned, Gerald is going to speak about today on the future of data and AI. And Gerald is a Senior Director of Product Management in Oracle, and he'll go a little bit more into those details. Again, I want to thank Viscosity for co-hosting these series of webinars since 2020. And I also want to thank Oracle, that being Gerald, for presenting his webinar today too. Thank you again.
Thank you very much. All right, good morning, good afternoon, everybody. Thanks for joining us today for my talk, The Future of Data and AI. As we have said before, probably best to just put Q&A into the Q&A box in Zoom, and I can get to it once we're through the slideshow. Today, I'm talking about the future of data and AI. Really, this is our vision of where we see what we and the data management industry as a whole can do to fuel AI, as AI needs access to the data, obviously, to give us the answer. So give you a little bit of insight of what's going on in Oracle database, what we're working on, what we have just released, and hopefully also give you a little bit of a glimpse what's going on in the AI space when it comes to vector databases and storing and analyzing these vectors in databases. Now, to take it away, let me see whether my cursor here disappears. Oracle's database vision is to make modern apps and analytics easy to develop, run, and leverage AI for all use cases at any scale. So really what we are saying is we really want to facilitate or provide a data management platform that you can use for any of your analytics or modern application development requirements. Make it easy to develop applications against the platform, against the Oracle database, to run these applications in production at any scale, and leverage AI. How do we accomplish that? Well, you may or may not have heard of this converged database approach that we have been talking about the last 3-4 years. So we want to provide a complete and simple platform for all data management needs. Now, the converged database is an architectural pattern where we say, look, rather than having to have multiple different databases, we provide it all in one database to give you a complete solution for all modern data types, workloads, and development styles, and a simple solution to add just SQL statements on the existing SQL language, not another database to support the requirements of modern applications. And we will see this later on as we go through the examples. Running on autonomous database. Now, Oracle database has been a converged database ever since the object relational days in the mid-90s. So an Oracle database, if you have an Oracle database today, it already supports multiple data types, whether it's JSON, graph, XML. Now also we will see vector, and of course multiple workloads as well. Oracle runs best on Oracle. We've always said this for a long, long time. So autonomous database is our premier cloud service. If you were looking into cloud, it's a fully automated end-to-end solution across the entire database lifecycle. It happens to run on Exadata, still the best platform or best machine to run your Oracle database on, sitting on Oracle Cloud, and now also you can get access to it via Google Cloud and Microsoft Azure. And of course, because it's a cloud service, it is cloud native. So it has all the things that you would expect the cloud service to have. Now, one thing I will call out that we actually see others do not provide, we have actually dynamic scaling. So that means you can add or remove CPUs from the database service by a click of a button, and we don't reboot the database to another VM shape like you would, for example, have on Amazon RDS, where you then do take an out time. We do this fully dynamically. There's basically no downtime to your workloads or to your application. Same with storage. Now, when we compare our converged database strategy over other strategy out there, we see really two camps in this, right? So I've just talked about what the converged database architecture is, basically adding more capabilities to the data management platform to facilitate new workloads, new data types, etc., in one solution, so that developers and IT can focus on innovation, meaning focusing on their business requirements rather than what we see being pushed through by a lot of NoSQL database vendors, and Amazon really is this single-use proprietary database concept. So where you have a database for a given task, like MongoDB for a document store, Neo4j for a graph store, right? Redshift for analytic, for warehousing, Snowflake for warehousing, etc. And then you having to integrate rather than innovate. So like what happens with this, if you go back like 40 years ago, the data management space has always been about breaking down data silos. We somehow, or these vendors have somehow convinced development that it's a really good idea to bring back data silos and put your data in a one trick pony solution, like your JSON documents go in MongoDB, and that's it, right? And then if you ever have to have access to the JSON data from another solution, well, then you use something like BigQuery or something else, and you have to use another solution and basically glue it all together. So it really, on a macro scale, it becomes a lot of a data integration effort. We think this is wrong. We think this is not what we should be doing. We think converged database architecture is the right solution. We also think it has been proven through the XML database days and the object database days that the converged database architecture is just a superior model, and certainly in the JSON space we start to see this as well. Now, the next generation converged database is Oracle Database 23 AI. We have just announced it we've announced it at Cloud World last year. We've just released Oracle Database 23 AI free on the 2nd of May, and Oracle Database 23 AI in Oracle Cloud, following our cloud-first approach that we had over the last couple of years. And the converged database approach has delivered really incredible value to businesses. We really have customers who said, hey, fantastic, I just need to upgrade my Oracle database to get this new capability rather than having to bring in another database in-house and then trying to integrate the two. But the further advances in the industry continue to push the boundaries of data management. Of course, the industry is always evolving, right? And so hence in Oracle Database 23 AI, you see our answer to that being a couple of revolutionary technologies that we have added to 23 AI to change or unify data management requirements on a more fundamental level. Now, when we just quickly go through history to just set the scene for what we're doing here, and again, for what we think is the right approach here. When you go back to the 70s, 80s, relational databases were created with the mission to ensure data consistency and enable declarative access to any data, right? So you organize your data in this relational model that was given to us by COD, and then you have this access method called SQL, the SQL language, where you have a declarative language rather than you having to implement how to get access to the data, right? You just state your intent, what you want to read, what you want to aggregate, and so forth, and the database will figure it out how to do that for you. If you think about that, like SQL just turned 50. The paper from Boyce and Chamberlain came out first like in 74, right? It kind of was standardized by ANSI in 84. It's been around for a long time, and it's really, really powerful. It's really, really like every kind of ranking that you look at or study that you look at from, what developer jobs can you get, or, what's important for developers, what's the number one programming languages and so forth, you will always find SQL in there. So it's actually kind of really successful that after 50 years, the inception of this concept, it's not just there, it's still really, really strong. Same with the relational model, right? But over the years, I was kind of called this, like, that call out that sort of like the students came out of school, it's like the grad school guys, like, oh, we have to reinvent the wheel. We kind of not reinvent the wheel. It's like, oh, there must be something better, right? It's like, I have this great ideas. And so we kind of end up reinventing the wheel. So about 10 years ago, 15 years ago, really more like these days, JSON databases were introduced, right, with the mission to make data management simpler for application developers. Actually, a lot of what you see in the JSON world was the same in the XML world, at least in the early days of the XML database world, right? So it's like, hey, your application already deals with JSON in and out. It's like, how about we just can store the JSON also for you? You don't have to go through object relational mapping. We make it really simple for you to kind of serialize and deserialize your JSON format to your application objects, to your classes that you have in your application code, and makes it all really, really, really natural to you. So it makes that super simple for development, but it forces the choice between simplicity of JSON for the developer versus the power of relational, right? The data consistency aspect, the deduplication, and so forth. Now, graph databases were introduced with the mission to make it simple to navigate connections between data. Graphs are really, really that data structure that makes it super simple to either detect connections between different data points or navigate through these connections, right? So they're great for querying. Let me just move here my face out of the way a bit. They're great for querying something like social networks, supply chain sequences of event. I always say when you go on LinkedIn and you see, this person of a third level via this person, that company, that skill, those are all graphs behind the background that are being used in graph queries that are being used to show you these connections, right? But again, you force the choice between simplicity of graph versus the power of relational, right? And then now vector databases, what we see now, have been introduced, right, with the mission to use AI to search data based on its semantic content, right? So to allow these large language models to do vector similarity searches on data stored in databases or retrieved from databases to give AI the answers that we're looking for, right? Now, when you look at this, it's like we are in this data silo world, not now for per se single purpose databases, but really like different workload requirements, right? It's like, so JSON is good for the developer who thinks in hierarchical formats like object-oriented applications. Graph is really, really good for traversing and finding these connections. And vectors, as we will see in a bit, is really, really good to help large language models to do something. And with all of these different requirements, then we have seen these single purpose databases spun up, right? So it's like most prominently MongoDB for JSON, Neo4j for graph. And then right now there's really like dozens of AI vector databases out there that are trying to claim that space, right? But what you cannot do is, like, you can actually, if you follow such an approach and fragment your data silos or fragment your data into these data silos, you cannot search for data using a combination of SQL, JSON, graph, vector, AI search, right? It's like, if you ever want to you have relational customer data, you have maybe purchase orders sitting in JSON, you want to know what products a customer bought, which other products he or she bought, and is therefore more likely to apply to your customer, and perhaps use AI on top of that for your customer to either interact via voice or upload pictures of what they want. You cannot just do this in such a layout. You will have to build an app that basically leverages all these different technologies and do it at the app layer, which of course is, again, as we said before, data integration rather than innovation. Like 80% you will spend on time integrating your data rather than to provide something useful for your users. Now, or an Oracle database, 23AI specifically, we have introduced a couple of technologies to help address these cases on a more fundamental level, basically to unify these worlds and eliminate the need for these data silos to fractured solutions. And the rest of this talk, we go through these three areas. We've seen, like JSON is still very popular for application development, probably right now, or the predominant data model that developers are looking for to use. Maybe it's swinging a little bit back. Graph, as said, is just the right data structure for analyzing and finding these connections. And of course, AI, now these vectors, which will give you a bit more of a deep dive later on, is the way to go for LLMs. They all operate on vectors. So the unification of JSON and relational, right, delivers a developer nirvana, the simplicity of JSON with the power of relational. That's really what we want to provide you. You may already know that we have offered JSON since 11 years, since 10 years, sorry, since 12.102, which came out in 2014. You can store JSON in a database, you can query it in a database. But let's go through a quick example and show you what the fundamental JSON data structure, the hierarchical level, what downsides this has. Now imagine you were building an app that creates a student course schedule, right? So a student can just go on the phone and they basically know when to show up where, right? Such a student schedule is probably, if you want it on a mobile phone and use JavaScript, Java, Python, really doesn't matter. It's probably easiest developed by using a JSON document for the student schedule, right? Where I just go ahead and say, yeah, okay, I have my student Jill, right? And then I have my schedule, which is an array with the different objects for the schedule. I can take this and I can basically traverse this document and print this on my mobile phone or her mobile phone for her information, right? Now, reading and writing the schedule as JSON document is super, super simple. It's basically just REST HTTP calls, right? Put and get REST calls over the wire, where you can just retrieve the JSON document and you can just send in the JSON document if you happen to update it or come up with a new schedule. So that makes it really, really simple for the development of the application. People don't have to think about, okay, what tables do I need? People don't have to think, it's like, how do I write it to the database? How do I join these tables back together, etc. But an inherent downside of storing JSON documents, like any hierarchical format, really, whether it's JSON, XML, etc., is that it suffers from data consistency issues. So, for example, all students taking this same course have a copy of the course schedule and teacher information in the document, right? Making updates really expensive and risky. So it's like there's obviously not one person going to Math 201, but there may be 20, 30, 50 people going to Math 201. Now, what happens if the room changes for whatever reason, right? It's like there's a maintenance issue. They now have to change the room to another classroom. Or what happens if Adam is out sick and another teacher needs to substitute him for him, right? It's like, well, you now have this duplicate data sitting across every student, and you now have to update this ideally consistently, or at least atomically for every student so that they show up in the right class, right? Now, querying that information also, if you were not coming from the application side, but just kind of trying to figure out, there's not one course in room A102, there will be 8 courses, right? Or 6 courses throughout the day. If that room is out of order, well, now querying that information, well, hey, which courses do we actually have? Which courses do we actually need to update for which students becomes inherently complex if you cannot use SQL for it, right? You can do it with these document stores, of course, but it's really complicated. It's not easy for a developer to do these kind of operations. And furthermore, updating that information across hundreds of students, right, for all these courses, there is no consistent way of doing this. You don't have a good, nice transaction over all of that to accomplish that with document stores. It's basically just like you have to start churning through this data and hope that eventually it will all be consistent, right? And this is what NoSQL databases have often said, eventual consistency. Now, whether it is consistent or not, well, the students will find out, right, whether they ended up in the right room or not. Now, JSON creates the severe issues when data is used for multiple use cases, right? So this is just alluded to this, right? But it's just like the students need their schedule, well, the teachers also need to know where they show up, right? So not only do we now have hundreds of students that have course information for the given room, but you also have to multiply this by teachers, right? Because they also need to know which courses to give and where to go, right? But their data structure is actually different, right? A teacher may not care so much about the student information, more about their course and their room. So you have the root element of this hierarchical data structure is now the teacher, not the student anymore. But again, it has duplicate data information of the course and room information, right? So again, like this is where all these inconsistencies come in, right? It kind of gets really, really hard now if you want to, again, change the room information for all these students taking all these courses and the teachers giving all these courses. In a relational world, this would be much, much simpler, right? In a relational world, you could just be like, yeah, probably get away with 4 or 5 normal normalized tables, right? And then basically just do a simple update, right, for wherever the room is A102 and the current day, right, to a new room, and you're done. It's consistent, fully transactional, ACID, everything, right? And you do it all with a simple SQL statement, right? Normalized rows are the single source of truth for the data that they store, right? This is really why we had the relational model. But of course, we know that developers don't necessarily want to use this model because they have to join multiple tables to retrieve the right information, right? They have to go look and say, okay, I have the student table and I need to join this with, well, I need my course information, but there's this third table in between to have an end-to-end relationship, student courses, etc. This is just complicated. I need always this what they call over mapping or object relational mapping, right? And this is what developers, students perhaps as well, but what developers always want to avoid, right? They don't want to have to think in relational tables and joining and so forth. They want to focus on the application. They just want the information, right? They don't necessarily care how it's stored, which then often causes these data consistency issues. Now, we have introduced a new functionality called JSON relational duality in 23 AI that eliminates these trade-offs. So just a quick pause here, right? So we have, of course, relational is how we started an Oracle database, and we have JSON support since 12.102. I mentioned that before, since 10 years. And that allows you to store a JSON document in the Oracle database as is, query it, and update it. And a lot of the things we've just gone over here, you could do fully transactional with SQL, namely updating these JSON documents. But the inherent problem what you have with these hierarchical documents is you still have duplication of information, right? You still, rather than having one entry for course and room in a relational table, you have hundreds of these entries across your teachers and students, right? So if you have a use case where you want to store and retrieve JSON and the JSON is more or less immutable, you can store this in Oracle database natively as JSON without JSON data type. What we've done with JSON relational duality is actually still deliver the simplicity of JSON for developers, but actually backing this with the relational data, with the relational model. So really what it allows you to do is you can now define, and we'll see this in a second, actually, let me go through this one by one, I'm getting ahead of myself. You can now store the data as rows in relational tables, right, as we have seen here before, right? Which provides you the benefits of the relational model, provides you ACID transactions in SQL, right? The consistency, declarative queries, and so forth. So think of it as a relational model. You store the data as a relational model, as we've just shown here. Now, you can include the JSON data type if you want to facilitate something like flex fields, right? Or something where you say, there's additional attributes that may differ from entry to entry. Usually people call these flex fields. That we really cannot predict and that we really cannot model. So you could store JSON information in that table with a JSON data type as well. But the real power of JSON relational duality is you can now create these new JSON duality views that essentially describe the mapping between the relational tables and a JSON structure. So remember, we just said that, developers really don't want to think about how to join these tables together and get to some hierarchical structure that they can easily use in their application. Well, they no longer have to. You can now, either as a DBA or the developer, define this relational duality, these JSON duality views that do this object relational mapping from relational tables to JSON for the developer. So there's a couple of aspects to that makes this really, really, really interesting and people are very excited about. So number one, you can use GraphQL. GraphQL syntax got popularized a couple of years ago. Is basically of JSON format. So you see it looks a lot like JSON over there on the left-hand side. That gives you this output on the right-hand side. Now, how does this look like? Well, basically, you tell us which tables you want in this nested hierarchy, right? So we start with the student table because that's the root element, right? And then we go into the schedule, which is the student courses end-to-end mapping, and then go down to the courses, and we go ultimately down to the teacher. Now, you can do some form of denormalization. You see on the teacher down here, we're using this app unnest, which basically means rather than introducing a new sub-object in the JSON, with just basically the teacher name in it, we actually take this attribute and push it up into one level higher, basically make it part of the courses document as we have seen it before. Next, you tell us which JSON attributes you want to have. Yeah, so basically tell us the table columns that hold the values that you want to see as part of this JSON structure. So if your column names are the same as you want to expose them in the JSON document, well, you don't have to do any mapping to it. Otherwise, if your column names, you use something like usually a bit shorter, especially when your database has been around for a while, like STUID, right, for student ID, or S name for student name, you can map these to any name you like in your JSON data. We have already actually seen it also here. Rather than saying student courses in the table name, we actually called it just in the JSON schedule. All right. So you give us which tables you want, the hierarchy you want to expose them, and you give us the columns that you want to expose as JSON attributes, right? And then users can now go ahead and simply query these duality views rather than the actual tables via simple REST get and put call, simple REST get calls, excuse me, right? So like just as they would have treated let's say a REST API from any other microservice, right, where they just say, please retrieve me that information, they can now do the same thing with Oracle Database. They can send a REST get call, right, to the student schedule relational JSON relational duality view. With the information, it's like give me the student for chill, not the schedule information for student chill. And so now for these developers, it becomes just like any other document store, or actually even more so like any other REST API. Now, the power of this is you can actually use REST APIs, but you can also use our MongoDB compatible API if you wanted to do so. And you can use SQL as well. You can query those duality views. And in each case, whenever you hit the duality view, the database will basically say, yes, I know the structure of this, I know the mapping, and we will do the joins for you. So that's really easy to get the data out. Now, much more interesting is actually the update, because a lot of people can actually get data out in JSON format, right? You can even use SQL JSON to get the data out. Now, much more interesting is the update. So with duality views, you can actually send a JSON document now to the database, to this duality view, right? Again, via a REST put call with a MongoDB API or SQL update statement, and say, here's my JSON document duality view. And the duality view will take this JSON document and say, I know exactly the mapping what happens, and will actually decompose that JSON document and update the right columns or cells in the right tables. So it will take the JSON document, it will identify, okay, I know here are my 4 tables, it will identify which columns have changed, which attributes have changed in the JSON document. And then do the corresponding either insert, update, or delete in only that row where there has been a change. So it will not just rewrite everything across the 4 tables or potentially 40 tables, but it's smart enough to actually detect the changes and only update what needs updating. And this is the really powerful aspect. This so far, no ORM system has really managed to facilitate, because they don't really know when the data changes in the database, what has changed, right? So it's like, because obviously, just when you want to send information back to the database, somebody else may have already done an update on these tables as well, or by another put call on this duality view. So, the data may be out of sync from what is coming back from the JSON document. Now, an ORM mapper, these libraries don't know that, because they sit on the application side. They have no clue once you retrieve the information, what has maybe changed in the database since. And that's why they have these optimistic and pessimistic blocking strategies. And they're really, really not good for throughput. Now, the other really powerful thing about JSON relational duality is that you can use the same underlying data and customize it to each app use case. So remember how we said before, well, you have a student schedule, but you also have a teacher schedule. They also need to know where they need to show up. Well, perhaps we have a course curriculum, right, that also says, hey, actually, which courses do we give where, right? All of these can be represented and updated and modified via these duality views by creating 3 different duality views with the hierarchical structure desired, but it's all backed on the same relational tables. So therefore, you have never a duplication of information. Even when you have an update, when a teacher says, I'm out sick, and calls in, and the maintenance guys change the room, right? And you have to update room and teacher information. You have ACID transactions allowing you to do this consistently without any of these applications actually knowing that. They just send you back these JSON documents. Now, the other thing you can do is you can still access these tables and modify these tables directly as well via SQL. So let's say the course curriculum application actually happens to be a relational application, doesn't care about JSON. So yeah, they can modify the underlying tables directly. They are just relational tables as they have always been, right? There's no need for that. The duality views, again, because they know the structure, because they are in the database, because in the end, they also just use our SQL execution engine under the covers. They are always consistent. They are fully transactional. It's like as it would just be like as if you have two different transactions updating the same table, the same row with two different SQL statements. So now you can mix and match these use cases, and you can build a duality view for each particular use case and expose these new REST endpoints with these payload structures, but it's actually all backed on the same relational table, which means data is never duplicated, therefore it's always consistent, and it is really much better for updef than JSON databases, right? Because like the developers get the simplicity of JSON, but they will not shoot themselves in the foot with data consistency issues further down the road, right? So they get everything that they want, and usually the data guys like you, if you happen to be like a data scientist or like data analyst or any kind of CIO person, you get what you want. You get consistent data, always never duplicated, always up to date, always consistent, always reliable, right? So the best of both worlds. Now, the nice thing is like when we come back to the JSON, when we come back to the converged database story, right? It's like, how can you leverage this functionality? Well, it's like if you have a database that's there for 10 years, 20 years, 30 years, it really, an Oracle database, it really doesn't matter. You just upgrade to 23AI, right? And I know it's not available on-prem yet, so you may have to still wait a little bit longer. But once it is available, you just upgrade your database to 23AI, and you can start actually exposing your already existing data from 10, 15, 20 years ago via these JSON relational duality views. No data transfer, right? No integration, nothing. You just start creating these duality views in your database, and you got it. So really, really powerful. No need to drag in another database to kind of facilitate these JSON document workloads, and no need to actually duplicating the data into that database. To finish off with this section, here's a quote from Carl Olofsson, research VP at IDC, one of the leading analyst firms, right? He says that Oracle's JSON relational duality, a truly revolutionary solution, is perhaps one of the most important innovations in information science in 20 years. So he's really, really excited. A lot of people that are into data management are really, really excited about this because it really gives you the best of both worlds. Now, moving on, unification of graph and relational, right? Navigation simplicity of graph with the power of relational. So in 23AI, we have introduced these new property graph views. So we have label graph support and RDF support for a long, long time. Property graphs have sort of kind of taken over the industry in the last decade or longer, depending when you started looking at the timeline there. But property graphs are basically the way to go to traverse and find these connections. Now in 23AI, you can create, just like you could create JSON duality views, you can create property graph views on your data. And that enables developers to treat data as graph vertices or edges, these two fundamental elements to graphs that you need. So as we said before, graphs are really the data structure to query or find these connections and relationships between data, between endpoints, right? And so here we have an example where we say, hey, we want to discover indirect money movements from bank account B to bank account E. So basically bank account B send it to an intermediary, and the intermediary send it then to bank account E, right? We kind of want to detect that pattern and see whether this is legitimate or not. Now, what you do in 23AI, you would have, like for graphs, graph has these as set vertices and edges. So the vertices are basically the bank accounts that we're looking for, right? And then the money transfer, these two relational tables, those will be our edges, right? So you see here, right, the connection of like B sending money to C, D sending money to E. Those are edges in graph lingo. Now with 23AI, you can create these property graph views, right? So it's like very similar to before. You say create property graph, give it a name, and then you have these vertex tables, right? So the vertices that we said before, and these edge tables. So we've just said, the vertices are the data points that we're looking into. So those would be, in this case, just our bank accounts, right, that we want to look at. And then our edge tables, again, is only one that we're looking here for, would be our bank transfer table. And then in there, we again say what columns do we want to expose in the graph, right? So that we can query on. Well, from the bank accounts, we need the ID and the balance. And from the bank transfers, we basically we want to have the source key, like, finding out the direction. So this is the from account column, right? That goes back to our bank account, and the destination key, that's the to account column in bank transfer, referencing back to our bank account's ID, right? And then we expose there the properties, or the columns amount and to account, like where we have sent it to. Now, once we have done that, you can write a graph query. So graph SQL, the SQL standard actually added this graph query. They call it PGQ, property graph language, property graph query language. You can now write this SQL statement that has this new graph table operator that essentially allows you to find these relations between the different graph properties. So this looks a bit like not quite SQL anymore when you look at here into this graph table here with, the bank graph that we have defined, but it says like this is sort of property graphs have been around for a long time. And this is sort of the lingo that they have been using ever since. So it makes a lot of sense if you've dealt with graphs. So when you start dealing with graphs, it will start to make sense for you to understand this. It's really not that hard. You basically say, okay, entry point, you call it V1. And then basically where the edge that you have is the bank transfers table, right? And you want to find the intermediary. So from B to E, but one intermediary in there. So you're basically looking for one and the third hop, right, in your graph, because E could obviously have moved money to another bank account and so forth. Well, you don't care about that anymore. You really care about the first and the third hop that you have. And you call this V2, right, the other side of the graph, the ending side. And then you're back into somewhat relational SQL. You say, okay, where your V1 ID, the bank account ID, is B, because we wanted to look from B, and your V2 is E, right, because we're looking from bank transfers from B to E. So source, target, how many hops, how is the hop defined, right? It's like this bank transfer table that we're looking for. And then we just aggregate the other account, so basically the 3 hops in a comma separated list, and we select that from. Now that query, as alien it may look like for people who haven't really dealt with graphs yet, is much simpler than to try to do the same thing with pure relational SQL. You can, sorry, with SQL, I guess. You can do it with pure SQL, but it would look like something like this, right? A query with 12 joins and 3 union alls to handle all the combinations of intermediary. So yes, you can do it with SQL, right? But it's like the graph table or the property graph query language is much more concise and gives you much more flexibility, because you will see here it's like we have 3 times a where clause, right, with B and E in there, and so forth and so forth. While in the previous example, we only defined this once in a simple where clause. Really, really powerful. So powerful that Ron Westphal, from research director from Futurum, says, now any enterprise running Oracle database can benefit from simple declarative graph navigation on all the existing business data. And that's really the crux to it, right? It's like, again, you have a database there for 10, 20, 30 years. You kind of wonder, I always wondered how these columns relate to each other, how these tables relate to each other. Have we ever, not in a relational sense, but like, have you ever seen patterns in the data, right? It's like, as such bank transfers, or as such anything of like, does how do our shipping actually, how many hops does it take to ship a product to a customer, and so forth, etc. Really easily done in graphs. Now you can provide those graph views on top of your relational data and start writing these graph queries straight in the Oracle database. No need to get a graph database in there. Get the data all out, put it in a graph database to run that in the database, in the graph database. Now, with Oracle Database 23 AI, one part of an app can treat the data as relational, while other parts can treat the same data as a document, and others can treat it as a graph. And this is also a really, really important point to make. So it's like, it's the same database, it's the same data. So there is no silo within the database. You can access the tables relationally. You can access the tables as graphs, right? These property graphs. You can access the data as JSON, via the JSON relational duality views, right? You can create this graph and JSON duality views on top of the same relational tables it doesn't really matter for the Oracle database. You can access the data and get the best of all these worlds at the same time, right? And it's a huge benefit, not only for developers and up there for productivity, but again, for your data consistency. No need to have data silos, etc. By the way, all of these features I've just mentioned, no extra option, right? It's actually part of the base product, will be part of the base product when it goes on-prem as well. So you don't need to buy an extra enterprise edition option. Even if you happen to be an SC2, you will get this all for free. Just all you have to do is upgrade, right? Rather than buy another solution. Now here, one more from Mark Stamer from Wikibon. Developing new apps using a pure JSON or a graph model is now like committing to using a basic flip phone for the next 20 years. And we also think that is quite true in that statement. Now, last but not least, let's look into AI and databases and the unification of these, right? So for that, we have to take probably a step back. At least we like to take a step back to explain this, right? So it's like AI, these large language models, they use a data representation, a data structure called vectors, right? Vectors is very well known. You may have studied this in college yourself and so forth, right? But vectors are basically these things that allow you to represent semantic context of really anything, right? And a bunch of numbers, right? So it's like whether it's a image, a document, a video, you can basically create a vector out of either of these, which is a sequence of numbers, which we call dimensions, used to capture the important features of the data, right? So what's a feature? What's the data, right? So think of it, for example, vectorizing an image of houses. So you have an machine learning algorithm, usually called like a large language model, or a model, really an embedding model is what it's called, right? That is trained on houses. It knows what houses look like, so it can take an image and it can give you a vector representation of that image. So you will see when you feed this image through this embedding model, you will get a vector, and the vectors, a lot of numbers in there. Usually they're like, hundreds, if not thousands of dimensions, aka different numbers in there. And each number is significant, right? So the image model will be like, hey, it's like, I know what type of roofs we have, right? And for each type of roof, I give a different number, right? So it's like the number 33 represents this given type of roof that makes sense to the embedding model. I know the different decorations that you can use, right? Tiles, Adobe, etc. And again, I give you a number for that. So 42 is a specific type of decoration that makes sense to this embedding model. So each of these numbers, called dimensions, represent a different feature of that house in the picture, right? And again, these features are determined by this machine learning algorithm or by this embedding model, and they're usually hundreds, if not thousands, of these different numbers, right? Not just four. Now, what you can do when you have such a vector is you can do a similarity search of that. So you can basically compare how close these numbers in vectors are to each other. So if we collapse down this vector that we just had to the image to just 2 dimensions, right? To just like basically 2 numbers, think of it, right? Then we could basically put this on an easy chart, right? We have a dimension 1, we have a dimension 2. Well, it's like 1 goes to 1, 2, 3, 4, 5. And, we have like 2 images that have like a 4.9 and a 5.1 and a 5 on the dimension 1. And then we have a dimension 2, and that goes perhaps to 10, right? And we have these 2 images on the left-hand side that go to 1.2 and 2.3, and 1 picture that is, at 9.8. So we have these numbers, we can compare these numbers. And based on how similar those numbers are, again, if you were to put it on a 2-dimensional chart, you can see how similar these images are, right? So these Adobe style houses are way closer together. They're not the same, but they're way closer together than this Japanese style wooden house, right? Because the digits, the numbers, the dimensions and the vectors for the Adobe houses are closer to each other in terms of just distance of like arithmetics than the Japanese wooden house. And now there is well-known vector distance search algorithms, distance algorithms that you can use to compare such vectors for similarity, right? So for semantic similarity. So we know, because those 2 houses are closer together on the left-hand side, that they're more similar compared to the 3rd house, right? The 3rd house is really of a different style, right? It's not as similar. May still resemble the shapes or whatever, but the vectors have determined that, the decoration, the style of the roof, etc. These numbers are further apart from each other than those two on these Adobe houses. Now, the same thing works similar with, for example, words, right? When you kind of vectorize Word documents, right? It's like you feed it through an embedding model, it comes up with these vectors, and then you compare those vectors, and then you see, well, animals are closer together, again, on a simplistic two-dimensional space than states, than fruits, right? And based on this, these clusters that you have, you can basically say with higher confidence that a dog and an elephant are animals rather than states or fruit, because they're closer to each other. Now, the trick though to AI is answering end user questions requires business data, right? And Oracle Database is the leading repository of business data, right? Oracle Database, you obviously all run it, right? The world runs Oracle for their mission critical business data and more. So end user data, if we go through an example here, for example, you may have end user data like buying histories, interest balances, location, etc. It's all in a relational database, it's in an Oracle database, or product data, right? Product attributes, inventory, limitations, configurations, etc. So it's like if we take now this example of like, let's imagine we have a house hunting app on our phone, right? Where we can basically a user can basically snap a picture of houses and say, hey, I want to, buy a house that looks similar to in this picture, right? You snap it, you upload it in your phone, and then the phone will find the right house for you. Now, finding a good match for the user requires a combination of the semantic picture search with business data, right? So it's like if you were just to upload that house picture and say, hey, what does it look like? And give me all the houses that look similar and that I would like to buy. Really maybe doesn't help you if, it finds a house over in Europe that looks the same, or of course, tons of houses in Japan that look the same, right? You probably don't want to move or don't want to move that far. So you probably want to have some sort of location in mind where you want to look for this house. You probably also don't want to buy the most expensive houses that are out there, at least if you were me, but you have some sort of a budget, right? That you can really, what you can really afford. So again, this is business data, right? And so only when you combine the two, so it's like doing vector search and just the house images. Yeah, it sounds great. This is fantastic, but it's really the interest of the business data, the interesting part of the business data to find a good match for your user, right? It's like, hey, I want a Japanese style wooden house, in my case, in the Bay Area, right? For less than like the gigantic millions that they charge these days, which is why I can never find one of these houses, obviously. But I want all of these data points combined to find a good match and don't waste my time with a house, I said, in Japan or something for a couple of million that is unaffordable, right? Now, there's different approaches to how you can do this. So all these vector databases have popped up, right, that are really good in these vector searches and into running embedding models and vectorizing your data for you, right? And they basically say, hey, this is no problem, right? Alongside with your image data that we vectorize for you, just send us your business data over as well, right? And we will vectorize that as well, and then we can answer the question, right? But really now you're in this situation where you basically say, hey, you have an ETL job over to these vector databases. So like, for example, Pinecone is a good example of that, right? They're really, really good in vector searches. Actually, they say, yeah, no worries, man. Just send over all the business data. We vectorize that as well through our embedding models, or the embedding models you provide. And then we just do a similarity search on all of these vectors. So, right, then we have your location, then we have your balances, your interest history, and so forth. Now, you have to do this continuously, though, because that's an ETL process, right? So whenever your business data changes, let's say I got a pay rise, right, and now I can afford a little bit more. Well, I would like that information to obviously go into my search, right? I can afford now a little bit more. So therefore, you have to ETL this over again. Because you cannot really predict the questions of everything, right? It's like, I may want to look for a house today. I may want to buy a car tomorrow. Well, that may require quite some different information, right? For a car, I may not care so much about necessarily where I want to live, but more like the dealerships around the area, right? Whether I want to lease it, buy it, etc. What make of the car. Maybe what was my car history, right? What other cars did I have in the past? So you end up sending a lot of different business data to your vector database. So in order that the vector database can basically answer any question and not only one question for you, right? And since you cannot predict the question or the business case of what people are asking, your large language model or your vector database in the end, you end up pretty much sending all of your data, or a lot of business data over to your vector database. Now, here's one thing that we see a lot of customers being really interested about these days. They don't like sending their business data over to somewhere else, especially the really critical information. I don't like any of my banks sending over information to vector databases, about my financial situations, because vector databases, although they're really, really good for comparing and distance search on vectors, are not so good on searching on business data, but definitely not so good on securing the business data. So now you send all this information, the sensitive information, over to your vector database, and now it sits there in vectors, so it's not even human readable anymore. So is the social security number in there or not? Is it mine or not? How do I find out, right? So we think this is not a smart solution. We think the best solution is to add vector search to your business database, following the converged database architecture, just like we talked about before, right? And then it allows you to use both your business data and vectors when answering any question. There's no need to move the data, to synchronize the data, to manage multiple copies of the data, and so forth. And again, there's also no need for updating the data, sending it over again when my balances just changed, when my budget just changed, right? It's all secure in the same database. Really, what we've done is, like, rather than sending all your business data over to something that isn't very good in securing it, why don't we just bring vector search into the database as well? Vector search algorithms are very well known. Everybody knows how to deal with them, right? And this is why we're introducing AI vector search in Oracle Database 23 AI, and you can download this today, right? So vector search to find similar unstructured data combined with the powerful relational search on business data. So what does this look like, right? So in Oracle Database 23 AI, you have now a new data type, a vector data type, right? So you can create this house table where you have perhaps, you store the image raw as it is in a blob, and you can store the vector for that image in a vector data type, right? And then you can do vector similarity search on this information, right? So you can now say, hey, it's like, for all my houses for sale in the table that I have, where I have the vectors for, the user uploads this image here in the app, and that just becomes now a bind parameter to the query. And we just say, hey, show me the top 10 houses that look most similar to this house that I've gotten here for my input parameter, right? There's just a simple new SQL function called vector distance with the column of all the vectors that we have stored in the database in this house for sale table, comparing to the input vector. And because we don't want to see every single one, because it's a distance search, so there will be some that don't look similar at all, but they will still be part of or will still have a result, we order by this and then fetch only the first 10 approximate rows. So we get the 10 that look the most similar, or 100 or 1,000, whatever you want to do, right? Now, here's the trick, or here's the important part. You don't need any ML, and any DBA, any ML expertise, and any DBA and developer can leverage to this functionality or this SQL function to do AI vector search within minutes, right? Furthermore, and I apologize, I think it will just run slightly over for 5 minutes. I hope you can stay on. I'll try to make sure we stay in time. Furthermore, you can combine this vector search with business data, right? It's a SQL query. So we have here this order by vector distance search, approximate 10 approximate rows, but we can now just join in our where clause to, where the price is under the budget from my customer table and the city is within the search cities from my customer table, right? Wherever the customer lives. So you combine customer data, product data, the houses for sale, and AI search in 5 lines of SQL, right? One integrated solution, and all the data is fully consistent. And that is really the power of adding this into the database, right? Rather than actually sending the data out to a vector database. Now, Oracle Database accelerates AI vector search by using vector indices, right? So it's like, this is not just a full table scan. We have new vector indices that you can use to accelerate the search, right? And that's why you also see fetch first 10 approximate rows that leverages these indices. Oracle can partition these vector indices for improved performance, just like you can partition your tables and other indexes in the Oracle database. Well, you can also partition these vector indexes so that if you search for like an area in Boston, you don't even have to scan all the data for, Chicago, Vegas, etc. It's typical partition pruning on the city, which makes your search, thousands of times faster. For any of you who have seen partition pruning right in action, you have the same on your vector search, can vastly improve your performance of your queries. Right. Furthermore, Oracle transparently scales vector processing across rack cluster nodes, right? So you can run vector search across your cluster nodes if you want to do so with full data consistency. And of course, you can also isolate your vector search on a subset of rack cluster nodes, right? You can say, hey, maybe only rack node 3 is for vector searches, and rack node 1 and 2 is for both vector search and transactional OLTP, or perhaps it's just for my old business OLTP so that I don't disrupt that, right? And again, with full data consistency. We can transparently offload vector search to Exadata Smart Storage software, right? So offload, push down the vector search to the storage cells and Exadata. Again, gives you a huge performance boost on this one. And we can shard or distribute vector processing across geographical distributed databases with our distributed Oracle database technology, aka sharding, right? For unlimited scale and or data sovereignty, right? So that you have actually vector search in Germany stays in vector search in Germany, vector search in the US stays in the US or per state. And of course, you have all the other functionality in an Oracle database that you had until today on top of AI vector search. Parallel queries work, transactions work on your vector types. You can run analytics. You have baked in disaster recovery. You have baked in security for your vectors as well. And. So there's a lot there. Now, last but not least, let me round it up with generative AI and just talk you real quick through this. So semantic search is great, right? But it's like what we can do even do better by adding generative AI. We all really want to talk to computers, right? And say, hey, find me a house that looks like this. And, my budget is this and that. And then give me an answer back rather than me uploading that image. Well, so vector search and generative AI enables end users to simply ask natural language questions, right? That's what I just said. So basically, with AI vector search, you can map a natural language question also to relevant data into the database. That's the goal here. So that when users ask the relative question, what happens? We pass it on to generative AI. So think ChatGPT, right? You pass it on to the large language model and then get the information back to you. Now, here's the interesting thing, right? So it's like, think of generative AI as like a college graduate, right? It's like you have a model that's trained on something very holistically, right? It knows what houses are, it knows what cities are, etc. But it really doesn't know your business context. So think if you were to hire a college grad, right, who's gone through computer science, a smart guy, and you put him day one on your support call center, right? It's like, although the grad has a lot of general knowledge, he knows nothing about your products, your past product issues, etc. He can probably not answer any question from users saying, hey, this doesn't work, right? It's not like that he doesn't know. He has this general knowledge. He just doesn't have the context to your specific business just yet, right? So what if you could instantly augment the college grad with your product and product support information, right? So it's like if you can get them in, kind of put all the information in for the last 10, 20 years that you were in business of about your products and your support information. Now the grad can actually answer these questions for the user, right? And it's like he has to learn it. Well, the same thing is with generative AI. Generative AI have these generic knowledge, trained on generic knowledge, but we want to be able to augment generative AI with the vector database or with the data in our databases to retrieve detailed and often private content needed to answer the question, right? Data that you don't want to share. And this is called retrieval augmented generation, or short RAG. You may or may not have heard of that. So what does this look like? Well, so the user sends a question which is already vectorized by the large language model to the vector database, right? Well, the vector database finds the private content, so documents, like for example, like, hey, I want to buy a house in the Bay Area that looks like this and that, right? The vector database already finds my budget, where to search in the Bay Area, etc., stuff that I don't want to give to ChatGPT, right? But instead, ChatGPT sends, hey, here's the vectors for this question. The database goes like, yeah, I can take these vectors and add my similarity search with the other business information there without actually ever sending it out of my database. And then I just send you back the result to this Gen AI guy, right? To this large language model to help answer the question. And ChatGPT will come up with a question and say, hey, Gerald, there's 5 houses in the Bay Area that would fit to your budget, etc., etc. But I've never given my budget out to ChatGPT. I've never given my financial information out to ChatGPT, rather than I did it the other way around. So Yeah, using a similar process, you can, leverage generative AI, or developers can leverage generative AI to generate SQL queries in JSON duality and graph views, right? So it's like this goes a step further. You can basically now go ahead and say leverage generative AI. We have this functionality called Select AI. You can basically say, hey, ChatGPT, retrieve me all my all my product sales for my customers in the US, right? And ChatGPT will go ahead. It has some knowledge about, okay, how do I write SQL, etc. It then sends that to your vector database, right? The vector database has actually the information, basically sends a SQL statement to the vector database. The database will then execute that SQL and provide the answer, not only the answer back to ChatGPT, and ChatGPT will then present you with the results. But your data never left your database, right? So, but we are now in a stage where you can actually talk to your computer, right? And say, hey, please give me all this information. And the computer just does it. It's really we're just about into being in Star Trek, I feel like. So this revolutionizes application development, of course, right? It's like developers no longer have to come up with these queries, write these queries, etc., but they can leverage these generative AI large language models to produce them for them, which means developer will be much more productive than ever before, thanks to the innovations in AI and also the innovations that we have in Oracle Database 23 AI, specifically with this unification of these areas. So key takeaways, just real quick, right? We have this revolutionary new functionalities in our converged database technology. Again, the converged database is an approach. Oracle Database is a converged database where you can unify relational, JSON, graph, vector AI on and other data models on a more fundamental level than ever before, right? This eliminates the simplicity versus power trade-offs, right? It's like I want it simple, but then you don't get the flexibility and so forth. And it enables unprecedented productivity for application development. If you would like to find out more, data, AI, and Aptiv are rapidly transforming. There's a lot changing every week these days. Just scan this QR code or just search for Oracle AI vector search, which will probably bring you to the same website to learn much more. And with that, I will close my presentation here. Sorry for going slightly over. I apologize. I hope this was useful. And if you're still here and have any questions, I'm happy to answer them.
Awesome. Thank you so much, Gerald. I don't see any questions. So if anybody has anything, this is your last call for questions. But otherwise, while you guys think of some great stuff, thank you so much. Reminders, this is a recorded webinar. Gerald's going to give us his slide deck, which is going to be great. And you can find that plus the recording at NYOUG.org or at www.orapub.com, and you'll get reminder emails from us as well.
And there's one question, whether these features are free to Enterprise Edition. Yes, all of these features are free. No additional option needed.
Wonderful. All
Cool.
right.
All right.
Well, if that's that, Gerald, I hope you come back and speak for us again. That was a great presentation.
Oh, anytime. Yeah, and again, apologize that I ran slightly over there, but you
No
can
worries.
obviously you can tell it was like the 7 minutes that you took away from me in the beginning.
Yes, me and Coleman too.
No, thank you very much. Happy to come back anytime.
Wonderful. Thank you guys so much. Coleman, thank you. We'll
Thank you.
see everyone again soon at the next one. So head to nyoug.org or viscosityna.com and you can sign up for our next webinar like this. Thank you guys, and I hope you have a great day.
Thank you. Bye.